going to talk more about the quadratic equations, okay? So go ahead and hit enter, Tristan. All right, so first thing we're going to do is solve, and we've talked about all the different ways to solve. Factoring is going to probably be your quickest way to do this, okay? So let's factor this one. Okay, so I'm looking for factors of what to get me what?
16 to get you 6.
16 to get me 6. 1 and 16, 2 and 8, 4 and 4. Which one of those can I add or subtract to get me to 6?
2 and 8.
Okay, 2 and 8, and I need it to be a negative 6. So what are the signs going to be?
Negative 8 plus 2.
Good. Okay. All right. So I have x and x. So we split my x's up so they don't fight. Okay. And 2 and 8. And we said 8 had to be negative. This one had to be positive. Good. Okay. So far, so good. Now, what do I do in order to find out what x is?
Set equal to 0.
Foil.
Yes. Set each of those equals 0. So x plus 2 equals 0. So x equals negative 2. There's one solution. X minus 8 equals 0. Add the 8, so x equals 8 is another one. Please. Okay? All right, so that's one method for solving. All right, go ahead and hit enter. Hit enter. That's okay. All right, okay, let's look at this one. The next one is completing the squared. Why would we do completing the square? Does anybody remember why we would do it? Why would we use completing the square?
When it's not factorable.
When it's not factorable, okay? So when it's not factorable, what does this have to be in order to use completing the square? I gave this a really bad one. Does anybody remember?
What does what have to be?
What does the coefficient have to be, the leading coefficient have to be in order to do completing the square? Does anybody remember?
Even?
Does it have to be
1?
1. It has to be 1. Okay? So, yeah, they gave us a really yucky one from the very beginning. All right. So, I really don't want to have to do one. Like this one from the beginning. Okay, well, we're just going to go with it. All right, so in order to do completing the square, okay, we have to have this to be 1. Since this isn't factorable, does anybody remember where this goes, since it's not factorable?
use
On the other side of the equal sign.
Good, on the other side of the equal sign. And I always have them draw a blank equals. When we move that over, we have negative 7. Okay? So, remember doing that? Okay, so we said this has to be 1. All right? So one of the things I could do is I could factor out a 3. So I have n squared plus 7 over n, okay, equals something, negative 7.
Why'd you put 7 over n?
Because I messed up, thank you. Because we took a 3 out. I'm not gonna change it into a mixed number, okay? I'm just gonna leave it like that. Does anybody remember how we find what goes in here? There should
Oh,
have been an
it's
n.
b over 2 or negative b over
Can James Atkins and Alyssa Jackson come to the office, please? James Atkins, Alyssa Jackson. Thank you.
Who is that?
Negative b over 2, and then we're gonna square it. What is my b in this case? Does anybody remember?
7.
7
3.
thirds.
7 thirds, good. Negative 7 thirds, okay, divided by 2, and we're gonna square it, okay? How do we divide fractions?
Each
Change
flip.
flip.
Good, okay, so I have negative 7 thirds times 1 over 2 squared, okay? So what do I have inside there?
Negative 7 over 6.
Good, negative 7 over 6, and then we're gonna square that, so what does that leave me with?
49, 36.
Good, 49 over 36. Now, where does this go? Do we remember? This goes somewhere and this goes somewhere else.
The first one goes into the blank.
Good, 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 good. This one goes in here, so it's minus 7, or no it doesn't, I'm sorry. We use it here in a minute when we go to factor. Sorry. This goes here. Okay. This is the tricky part. Because they didn't make this easy and start us out with a 1 as our leading coefficient, everything inside of here is times
3.
So what do I put on the other side in order to keep balance?
3. Or the
3 times,
the 49.
what is 3 times 49?
A big number.
Like,
167.
56.
So 49 times 3,
147.
so I have 147 over 36, okay? How many of us realize that if I would have done this, that the 3 and the 36 would have reduced? Okay, they would have reduced and I could have just wrote 49 over 12. Okay, you could do that as well, all right? So just don't forget that. Okay, since we've done this, okay, I can now write this into factors. That's where this comes in, okay? I can now write this as a perfect square. I still have the 3 on the outside, okay? This is gonna be n minus 7/6. There's my perfect square. Equals, what do I have to do in order to put those two together over there? I need a something, a
Common denominator.
common denominator. If we reduce that second one, it'll make our denominator smaller, right? Does anybody remember what we had when we reduced it a while ago when I did the,
49.
wasn't it 49 over 12?
Yeah.
Okay, so what would my common denominator be? 12, okay. What is negative 7 times 12?
It would be negative 84, is it? Wait.
Negative 7 times 12,
Yeah, negative 84.
negative 84. Okay, so I have negative 84 over 12 plus 49 over 12, which gives me a total of what? What is negative 84 plus 49?
Negative 35.
Negative 35? Okay, all right, so I'm gonna write this over here so that we can kind of clean it up. So I have 3 times the quantity, n minus 7 over 6 squared equals negative 35 over 12. Okay? So I'm trying to solve for n. What would be the first thing I do?
Divide by 3.
Divide by 3. Okay? So I'm going to divide by 3. They cancel. If I divide this by 3, what's the rule?
Keep change flip.
Keep change flip. Okay, so I'm left with n minus 7 over 6 quantity squared equals negative 35 over 12 times, we're going to flip it, 1 over 3. What do I get? What's 1 times negative?
35 over
Good.
36.
Good, over 36. Good. Okay, so I have n minus 7 over 6 quantity squared equals negative 35, 36. How do I get rid of the square?
Square root.
Square root it. When I square root, we always have plus or minus. How do I pull out the negative?
I.
So plus or minus, I have an I. Can I split this up like this? Is that okay? Okay, why would I do that? What do we know about these two numbers?
Well, 36 is a perfect square.
36 is a perfect square, and if I can get rid of my radical in the denominator, I don't have to rationalize later. So I hope you're paying attention to this, right, Tristan?
Yep.
N minus 7 over 6 equals plus or minus root 35 over 6 I. Because our number goes in front, right? It's our number, then the I. What's the last thing I have to do?
Add 76.
Add 76, 7 over 6. So N equals 7 over 6 plus or minus root 35 I over 6. We have a common denominator, right? So can I write that all over one denominator? Absolutely. Okay, and I'm afraid it won't be on the camera. So my end result would be N equals 7 plus or minus root 35I all over 6. Okay, a lot of work. They gave us a really hard one to begin with. A lot of times that we won't end up with a fraction in here. Okay, a lot of times they'll give us something that's a little bit easier than that. Okay, so that is completing the square.
Yeah, that was a crazy one.
That
I
one
don't
really was a
remember
little
it
crazy.
being that hard.
Yeah, they get that hard, but
But I don't remember them ever being that hard like
to
last.
start with,
Yeah.
maybe not. Okay, so go ahead and hit enter. All right, quadratic formula, okay? All right, so this would be our other go-to. If we cannot factor, okay, we have all these options, okay? So once we can't factor something, we're gonna use the quadratic formula, okay? If it's not factorable, which is the quickest method, we're gonna use the quadratic formula next. Go ahead and hit enter, which everybody in here should be familiar with that, okay? All right, so they give us this equation right here. And they specifically say, use the quadratic formula to solve this equation, okay? I am not gonna have enough room on this board, so what I'm gonna do is t squared plus 80t all right, okay. Okay, so let's use the quadratic formula, which is what? X equals, somebody tell me.
Negative b
Mm-hmm.
plus or minus square root b squared minus 4ac
All
over 2a.
All over 2a. Okay, now, in case we have forgotten, this is our
Okay.
A, this is our
b
B.
B, and this is our
C.
c.
C. Okay, so we're gonna definitely need our calculators on this because these are pretty good sized numbers here. All right, so what do I put in for B?
80.
Okay, 80 squared minus 4a is negative 16. Okay, C is 3.5. All over 2 times negative 16. Okay, some of this we can probably clean up in our heads a little bit. Okay, so I have negative 80 plus or minus, that would be 6,400 plus, this would be 4, okay, that's 64, so we need to take 64 times 3.5. Somebody will have to help me out.
224.
224? All over negative 32. Hey, Trustin,
Yes.
what'd you get when you added those together inside there and took the square root?
6,200 or 624.
I know that part. What'd you get when you took the square root of it?
The square root of it. A big number and a smaller number.
81.3879.
81.379?
3879.
3879. Did anybody get anything different?
Nope.
Okay, we're going to have two solutions here, okay? The first time we're gonna have, okay, so the first time we're gonna have negative 80 plus 81, let's round to the nearest tenth, so 0.4 divided by negative 32. And then the second time, we're gonna have negative 80, am I still on the camera?
What?
Mm-hmm.
Okay, negative 80 minus 81.4 over negative 32. Okay, so here this one is going to reduce to 1.4 divided by negative 32. So I'm going to have a negative answer. What'd you get on this one?
Negative 0.04375.
Negative 0.0435.
375.
375, okay, so there's one solution, okay, and here we're gonna get a negative divided by a negative, so that's gonna be a positive, so what did you get on this one?
5.04.
5.04. Okay, alright, so this is how we would use the quadratic formula. Okay, any questions on that part? No, we're good? Okay. Let's put this back on. Okay. Alright, let's see if we were correct. Okay,
Seems like it.
which kind of makes sense if we look at our graph, how little we here. Good. So we were right. All right, go ahead and hit enter. Okay, so does anybody remember where the discriminant is located on here?
Underneath the square root.
Good. All right, so we use this to tell us what? What does the discriminant tell us?
The asymptote.
Nope.
Nature of the roots.
Yeah, and what's that mean? What
Like
kind-
if it's a real root or a complex.
Good, if it's real or complex, so it's gonna tell us if it's real or complex. Okay, alright. Does anybody know what this is gonna be if it's real?
Positive.
Positive, which means it's greater than 0, which is a fancy way of saying positive. Okay, what about complex?
Less than 0.
Yes, that means it's gonna be.
What if it is 0?
That is a really good question. What if I get 0 under there? What if it's equal to 0? What's that mean?
No solution? Undefined?
It's gonna be a straight line.
All real numbers.
It's gonna have one root.
There we go. Which one? Real or complex?
Real.
One real root. Good. Okay, so he brought up a really good question. Okay, so we're going to use that under there. If it becomes positive, we're going to have 2 real. If it's negative, we're going to have 2 complex. And if it equals 0, we're going to have 1 real. These are going to come in pairs of 2. Okay, all right, we're going to only use what's underneath of the radical. So go ahead and hit enter. Okay, this is exactly what we just said. Go ahead and hit enter. All right, so let's look at this equation. It says, find the discriminant So they actually wanna know what that number is. Okay, so we're gonna use the b squared minus 4ac. Okay, this is my b. What's my a this time? 1. There's an understood 1. This is c. Alright, so let's go ahead and plug these in. B is
-4.
squared minus, what do we put in for A?
1.
And C?
15.
Alright, what is -4 squared?
16.
Okay, think of the hands of the clock. 4 15s, that's gonna get me to 60. Good. 16 minus 60. What do you guys get? What'd you get?
Negative 44.
That's our discriminant. Now, according to that, what do we know about the roots?
Too complex.
Too complex.
Well, we know they're too complex, but
Okay, too complex. Now, we should already know this. When I have complex root, they have to come in pairs of
2.
Yeah. Okay, so they're gonna be conjugates, right? Alright, go ahead and hit enter. Alright, go ahead and hit enter again. Alright, so let's look at this one. Let's solve this one. What should always be our go-to? Should we always try to factor, or should we just jump right to something else?
Always try and factor.
Always try and factor. Are there factors of 6 and 2 that I can get 1 from?
No.
No, and they're all gonna be positive, okay? So what method do you wanna use? Would we wanna use completing the square here? No, because it's gonna give us a fraction. We don't have a 1 here. So,
Quadratic.
yeah. Alright. Okay, so what do I put in for B?
Or 1.
What do I put in for A?
6.
And C?
2.
And all over 2 times A is 6, okay? So I have -1 plus or minus,
This is an easy one.
okay, so 1 minus,
48.
all over 12. What is 1 minus 48?
47.
Okay, is that factorable at all? Okay. How do can I leave it like that?
Yeah. No.
What do I need to do?
Oh,
You gotta
I.
pull that I.
Pull that I out, okay? So we're gonna pull that I out. So -1 plus or minus. Is that the correct order? Is it I root 7? What's the correct order?
Is it?
I before E except after C.
Do we put the number in front of the I or behind the I?
In front of the I.
In front of the I. So I should have written plus or minus root 47I. Okay? Again, these come in conjugate pairs because the whole way we get the imaginary number is it's the square root. And anytime we take the square root, we have a plus and a minus. Okay, so these are always gonna come in conjugate pairs. Okay, go ahead and hit enter. And enter again. Okay, go back to one more. All right, so there we go. So you're gonna work on the problems that are on page 219.
Okay.
Okay, go ahead and you can stop that.